Welcome guys. So I got a pretty cool part today that I'm doing. So I'm going to show you a process. I've learned actually something new about a line left. So I'm going to share with you guys too. So let's not waste time and let's get to the root of this video. The part that I'm talking about is this. It's a long shaft. You have a grooving, flat, some milling, drilling, and such. Okay, so it's a pretty long program. So as with notes, pull out 3.5 inches from jaws, 2 inch with the bar guide inside. My tools are 80 and 55 respectively. So over here I'm starting 2 inches, 100,000, removing 140,000 from a face. I'm coming down to 0 and my Z is 0. OD turning. So the OD turning, I'm only doing, let me see, this section right here, which is the thread, and a little bit past the thread later is because this part does not allow center. And as you see later, I'm only doing this here, and then I knock this out up to here without support. All I'm using is a center and this like a, let me see, I'll show you. I make this like a flat button. So what I do is I press it on the face of the part and I bring the tailstock into here. And if you set up your speeds and feeds, you should be able to cut it without chatter pretty far. What I do is I break it into sections. So I do half and half. What I mean by that is, so I machine this first, then I hold the part here, and I machine here, finish it, and then I blend in this section. So at least it's got some extra material, so it gives it a little bit more rigidity. So OD turning up to like 2.7 inches, and then I do number 7 thread. So if you don't know, number 7 thread, the lead is 1 divided by 7. Sorry, 7 divided by 1. That's going to give you 148 and 2/8. Angle, it's 50,000. It's not actually angle of the thread, but the entrance. One entrance, 94 and 1 height. That's all automatically populated. And this is a 1 inch and 1/8 thread. And now, as you see, I have 2 bars. I'm starting one at 2.2 all the way to 12 inches, and then I'm starting 11.5 all the way to 19 inches. So I do start half an inch early, and then it starts up in the air, so 1 inch and 125, and then it goes to 1 inch and 19 at 50,000 before I finish the other part. So you have this nice transition, and you don't see a step. Then I have that groove out. So groove, this is pattern 1, so it's a regular. So that means you set your Z as a beginning of the groove. You add width of the groove. The finish for that I had set as a 2000. And starting Z and final point Z are the same because it's just a regular groove. Now flip and pull out 3.5. So I'm facing to size. I got a little section, as you see over here. I'm machining this section. So this got a thread, so it's just one diameter that's going 160. I'm using half an inch spot face as a center for a drill. I'm drilling the 550 drill, which is 14 millimeters. Packing, that's technically all automatically populated. It looks good, so I didn't mess with it, and I'm going 2.5 inches deep. Now I'm using a 3/16 bar because instead of a regular chamfer like 60 degrees or 45, I'm actually doing a chamfer 30 degrees where the thread is gonna be. And I'm talking about here. Why? Because I'm gonna use this as a center. So I'm gonna support the part. So if the center is 30 degrees and the chamfer is 30 degrees, it's gonna sit nice and flush and it's not gonna damage the beginning of the threads. So I'm throwing the chamfer there, which is 112,000 chamfer. And then I do two separate cycles for the thread. As you see, first one is 16 passes, and then I repeat 6 passes just to clean it up. And technically that's it. Now I flip the part. Okay, I'm gonna hold it here, and I'm machining all this radius here, and then the flaps. So it's running right now. As you see, so first I back turn to give me a little room, and then I just come down with an 80-degree tool and just run it all the way through. So as you see, I got a bar out, highlighted. Highlighted, that means there's a material that it's gonna cut into, and I use a 35-degree tool, and I'm going from all the way to the top down to 45 degrees. 45 degrees down to that 1.5 diameter, and then I come in and I technically blend in later with this 80 and go all the way across. Now line left. So let's talk about the first line left, okay, which is this one. So this is gonna be, see that sharp, let me see. The sharp corner is going to be my start, and sharp corner on this side is going to be my finish. Now, if it's not going to stop rotating, let me put something underneath. Okay, there we go. Now, the way that's going to be done, and I used to do like a closed kind of loop, right? So when I used to program, I used to go climb on a Y, go across, come down on a Y, and then come back to the front. Well, when I talked to one of my friends, and he's a mill guy technically, I kind of did it in reverse, because line left. So if you look at the part from here, you're supposed to go actually from the top. So let's call it like this. You're supposed to go from the top on your right hand side. You go to the left, and then you go on the bottom, and then and then you come up. And instead of actually coming down, going on top, and then coming down this way. So let me see. Kind of messed up. So we start on this side, go on a Y, go across here and here. And like I said, and before, I used to go from the top, from the bottom to the top, across, down, and then I'll come back, right? Now, the problem with this is sometimes I had like alarms, and it was just kind of pain in the butt to do that. And then, so when I talked to one of my friends, so technically what the machine used to do, so it would come up, go here, here, and then come here. And if, there's extra material, it would just kind of do this, right? Now, if you program it as a U and don't close it, what the machine does, it comes down, comes across, okay, comes up, comes back, sorry, so actually it starts here, comes across, okay, like here, then comes back, then comes down here, and finishes this section off, then comes across and goes up and finishes this section off. So it only actually machines this way. And you can actually take way bigger cut, because this is what they call climb milling, which is what you're supposed to use in CNC, because we have servo motors versus like if you have a Bridgeport manual, you're supposed to do like a standard milling. So this actually works out much better, way faster process. There's just less wasted time. So let's kind of get back to how the program is written. So, okay, so we have a line left, we have a Z and Y, right? Because we're going to be traveling, technically Z, we're traveling across on a Z, and then we're moving on a Y, and the C does not technically move. It only stays on a position C that we set it onto. So position C, we are removing 125,000. Okay, so your finish point from the center, not on the diameter. Remember that center is 625. If this will be rounded, that means we got a 1.25 inch diameter. Okay, so from the center it's 625. That's the bottom, okay, of the part, and we are removing 120. So the machine's gonna come that 120 higher, and it's gonna drop down to whatever depth of cut we're gonna set this to. And we are removing 1 inch from SRVR, which is from diameter. And what I mean by that, so let's call this one. We're telling her that this flat is 1 inch, but the depth of the flat is 120,000. So what happens, let's say if you tell the machine you got 800,000 on R, you might have a step over here, right? Because it's gonna come down and it's gonna go across, and it's gonna leave that because that's 800 instead of 1 inch. So that's what the SRVR is. And then your rougher and finish, and how much you wanna finish on A and R. So I just put it 10,000. My start and end is open. There's no interference and no chamfer. So here are my end mills. So I'm using 5/8, so 625. Approaches are set automatically. I'm doing 110,000 cut. So it's gonna do one roughing pass and then one finish pass. The width of the cut, it's a half an inch on I set it on a 5/8 end mill. My surface speeds are 220 and 240 with 10,000 feed rate on rougher and finish. So now, the first line, we're telling her that the bottom of that flat is going to be 625. Okay. Now, my starting Z position, it's going to be 972. Okay. So 972, it's going to be that corner. Okay. And then we are 600,000 on a Y. All right, so we got that 972. All right, this is starting, and this is 600 and minus 600 on the bottom. So 972 on Z, 600 on a Y. We are staying on the same Z position, but we are going down on that 600 on the Y, right? So we're going 600, telling her go down, same Z position below, so on a -6. So it's got a 1.2 inch swing from the top to the bottom on the Y axis. Now, so this is going to be the second one, right? And then on that 6Y, we're telling her move from 972 to 13.59. So now we're going all the way here till we hit 13.59. Okay, so now we're here, as you see, and now we're staying on a Z position, 13.59, but we are going up on that on the Y to 600. So now we're going back to 0.600. This is minus and this is minus. So as you see, we're going from 600, right, on that 927, down. We're going across and we're going up. And when you do that, the machine technically comes down here, does the pass with tracks, comes back here, does the second pass, and then it comes back and it finishes everything up. So this is that long flat. Now This part also has 3 more flats, but these flats are 1/4 inch deep, and as you see, this one is much bigger. It's much longer than this one. So this is where I got that little edge where it didn't clean up the top, and I'll show you why. Because, so same thing is, line left, you can technically copy everything. You adjust your position to 180 because it's a cross. We are removing this time 250,000. And my shift R is going to be 1/2 inch from the center. So that means if it will be uniform, then you would technically have a 1 inch on the diameter, right? So this time shift R is 0.5, and we're removing 125,000. I changed the SRVR for 20,000. This actually doesn't matter. It kind of made no difference to me. And the reason why is because the smaller ones, the end mill is so big that no matter what it does, it cleans everything up, right? Because the end mill is like technically this. So no matter what it did, it cleaned it up. Okay? Now, so this was the smaller one. Let me see. As you see, it goes to from 972 to 2 inches. Okay, so it's like 1 inch, a little bit over 1 inch, not much, and 5/8 end mill. They're technically, no matter how you're gonna break it down, everything will clean up. However, that middle one, this one right here, it is much wider. And what happened was when I ran it, and like I said, it left that. It cleaned everything here. It cleaned everything here, right? But it left a little lip on top. So what happens is because now you have way more coverage to pay, and because you go deeper, then you also have much more SRVR to remove. So the reason why this one didn't matter is because it's 5/8, so technically no matter how you're gonna run it, everything would clean up. But if you use a 1/2 inch or 3/8, it would not clean up. You would actually have to, that SRVR, you would have to measure between here and here. And as the bottom, because it's more shallow and it's closer to where it is, so the diameter was much smaller, right? Let me see. Let me grab to kind of show you what I mean. So this flat, is 800,000. But since this one goes deeper, as you see, this one is 1 inch and 180,000. Okay, so that's why it didn't clean up. So all I did was I added that SRVR 1 inch 0.2, and then it did an additional pass. So because now the machine knows that that this diameter is 1.2, but we set the cutting tool, right, as a 5 inch. So 5 inch, so knows that 5 inch will be here, 5 inch will be here. So it's missing additional 200,000. So that's that extra pass, and then it cleans everything out. So this is, like I said, in some instances, it doesn't matter what are you gonna put here. But if the surface you're covering is much bigger than your end mill, then you have to be a little bit more specific over here, so the machine knows that that you just have more cleanup. Now, I don't know if it's gonna allow us, but if you have a question mark, as you see, the finish A and your finish R. So your finish R is technically the width. So you could see from here to here, and finish A and SRVA is technically your depth. Now, it's hard to kind of say that, for example, if you got a bar, right, and you need to, get rid of this, well, how much is from here to here? So I kind of had to eyeball it. In all honesty, I'm not that good in math. You could probably calculate that. You could probably figure it out. But like I said, I mean, for me, I just kind of eyeballed it. I went originally 1 inch, and I saw it left it, so I added 200,000 to it, and I kind of cleaned up. So this is the same thing as, but so once I had this program, and then I had 3 more. So I've made first one, I copied the second one, I copied. All I did was I changed the approaches, did a question mark to approach, and I kept this because everything stayed the same. The only thing that I've changed was the starting Z and my finishing Z points. Everything technically stayed the same. Now, line center. Okay, so I have a chamfer drill, and the chamfer drill, I use it as an end mill, and it says 0.5S. Then I got a chamfer out and drill out. Okay, so I got one tool that's doing 3 different jobs. So line center, let me see, it does a single pass for chamfer. So if you look at this part, the line center goes from the top on the right and from the bottom to the top on the left. Same thing on the right. Always right, you go from the top to the bottom. On the left, from the bottom to the top. Next one, from the top to the bottom, from the bottom to the top. These are my line centers, okay? So same thing, you see line center Z and Y, position C 0, SRVA, 100. It doesn't really matter because I'm only doing 1 pass as a finish. I'm not doing any roughing. So all these things technically are, are technically valueless to me. So I set it as an end mill, but I called it 5.S, so spot face, or you can throw in a chamfer. Automatically populated approaches. My speeds and feeds are 170 to 3000. And all I do is I set that 625 from the center, 982. Right, so the reason why it's 982 is because these spot faces, they have about 10,000 to 20,000 flat on the bottom. So as you see, 972, and this is 982. So what I was told, if I have a flat and you run the chamfer drill, right, so you're gonna run this drill like this, and then it's going to come down on this side. Bring here and here about 10,000 on each side. Okay, so when this was supposed to be at 972, I went to 982. As this supposed to be 1359, I brought it back in to get it tighter, right, to 1358. So remember, the end you bring it to the inside, and the beginning you bring it to the inside as well. So get them a little bit closer, and what that kind of gave you, nice, beautiful, clean corners. Okay, so we got a line center. So we have we got 4 flats. So 4 flats, you got 8 line centers. Now drilling. So I use that chamfer drill also to give me a chamfer. I'm using a 420 drill. So 420, I'm going 220 deep, so that's going to give me 440. Plus that's 10,000, so it'll give me like 20,000 chamfers. Drill out, 0.5 spot face. Now you see hole diameter 1/2 inch. We're going 20,000 packing, 100,000 depth, 120 surface speed, and 1,500 feed rate. My starting point are, again, 5/8, so 625, C0. Now this is gonna be that center. So as you see, this one's got a center, but these are like a little bit to the side, and then this is also in the center of the smaller flats. So I'm getting my chamfers everywhere, and I'm getting chamfers on both sides. So once the drill goes through, I also have a chamfer on the other side, respectively. So as you see, chamfer here and chamfer here. So as you see, this is 125 and this is a 1/4 inch thickness. All right. And so over here, now we're technically at a drill. So same thing as drilling, sorry. 420 diameter, we're going 1.3 inches deep. 420 drill, 420 hole diameter, 1.3 deep. So these are technically being brought from the top to that middle line. And then we do packing number 2, do a 1/4 inch packing, 120 surface speed, 3000. And now we're doing point because it's 625. It's going to be that starting diameter. And my center is going to be 1 inch 531 and 0 on the Y. Same thing as 625, 625, 625. So I'm only drilling technically from that more shallow side. So right here, right here, right here, and right here. So 4 drills and 4 holes and 4 drills. You can, I mean, if you can be specific, you could technically, if you got a large, like a large diameter part, you can drill from the top, rotate the part, and then drill across again. So technically, this is the program now. So just remember, like I said, if you're gonna program and you're gonna look at the part, and let's see the part. Hold on. So as you see, the bottom flat is already done. This is running a finish. So see, it went down, and on the left side it goes up. Now it's running a finish. Okay, so it ran the rougher 3 times. The last cut of the rougher, I just noticed, it's not big enough. So what I'm gonna do is I'm gonna increase the size of the depth of the rougher so it only does 2 passes instead of 3. So that's gonna save time. So now we got the chamfer going. So this is that line center that goes from the top to the bottom, right, on our left, right side. And then once it's gonna do the other side, it's gonna go from the bottom to the top. It's funny how it looks that chamfer mill, that it's rotating very slowly, but it's actually rotating super fast. It's just the frames are not catching all the rotations. Okay. And now we're going from the bottom. Let's see if I can get a better shot. Alright guys, I see I'm already hitting over half an hour on this video, and I know how much you guys love these long videos, or you actually not, so I'm gonna finish it. But hopefully somebody gets some value out of this video. Thank you for spending some time with me, and see you next time.